Worksheet 8C, and the question have the maximum moment in the beam. So throughout the beam, the maximum moment occurs halfway between B and C, and it equal to 100 foot kips. So that is the M max, moment max, throughout the beam. So when you design for the maximum load, in this case maximum bending moment, and it will be safe for all other locations throughout the beam. How we determine the why people know that is the moment max at the somewhere between B and C, halfway between B and C. Next lesson we will learn about that. But for now, let's accept for this beam with that load, the maximum internal bending moment is halfway between B and C, and it equal to 100 foot kips. The beam is made of A36 steel, so they give us the material, and so that is the sigma failure 36 KSI, and the factor of safety 2 with respect to yielding. Select the most economical wide flange beam. With that question, you go back to similar problem we do it in buckling for column. Worksheet 5C also ask for the most economical wide flange beam. So go back to see how to determine the most economical in that worksheet 5C. Now we can move a little bit faster with that in mind. So in this case, you determine the most economical wide flange. So basically that is the design problem. So when design problem, apply the general design equation, right? So allowable actual is less than or equal to the allowable. So when you design, that's what you have. And in this case, the actual is if you recall, the sigma moment max equal to MC over I, and if we set the section modulus equal to I over C, then we have M over S, which is the sigma max. Have to be less than or equal to sigma failure level divided by the factor of safety, divided by the factor of safety. So with that, what do I have? I will have the S greater than or equal to M moment time factor of safety divided by sigma fail. And for that one, sigma fail is basically the yielding, right? So it will be equal to sigma M factor of safety divided by the yielding stress, sigma Y. So from that, all we already know as plug in as moment given maximum internal bending moment 100 foot kips, plug in 100 foot kip. And in here we talk about inch, so change that to inch kips. So we can time 12 inch per foot. And then we time the factor of safety. In this case, it equal to 2, plug in 2. Sigma fail equal to yielding stress 36 KSI. So unit is very important here. We need to make sure we do correctly. All here is inch. Then foot have to change to inch. So from that, every number good. We have S equal to section modulus equal to 6.67 inch. Recall it I over C, I inch 4 divided by C inch, so it will be in 3. So when you have that, it recall the I wrote down here. Review worksheet 5C, okay, for uh, selecting the most economical wide flange beam or any other cross section, right? Wide flange beam. So from that, as you can see there, we review that. That where we go? We go to Appendix C. Okay, so why that I talk about the Y, the standard shape earlier in the demo. So it will be Y flange beam properties in Appendix C property. In Appendix C of the textbook. Okay, so with that, go back there. What do we need? We need the section modulus S, and at the way the beam put in this case have to be equal to at X, because that the most economical way to set up the beam as I show you in the demonstration, and that have to be greater than 66.67 in 3. So from that, go back to your reference. Go back to the reference here, Y flange shape, and look for the SX. Okay, so we have SX section modulus for the axis SX because that what the beam should be set up. That will get the maximum ice to get the minimum flexural stress on that beam. So we will set up this way, not rotate the beam 90 degrees so that you can get a smaller S in Y. But when you set up the beam, set up that way. So go to the SX. So SX here have to be greater than 66.67 in 4. So you just take time, go down, and see multiple candidates. And then you can select the one that most economical. So let me give a few here that you have. For example, if we're talking about the W16, then you will have 16 by 57. The SX equal to 92.2, greater than 66.6, right? For 14, W14, I can select 14 time 53. So you have SX equal to 77.8. Then go up, keep continue, be patient. The next one, for example, W21 by 44, you have SX equal to 81.6, and have multiple ways that you choose. But when you choose, you need to choose the most economical. So look at the one on the candidate and look at the one that have the the least weight, so that you don't pay a lot. So that is the second component. It turned out to be the W21 by 44. It will be the most economical cross section, the Y flange for this problem. How to find out multiple candidate again, take some time. Go back to lesson, the worksheet 5C, so that you can be able to review how to find out different options and select the most economical option. So in this case, you will choose the select W21 by 44, because 44 pounds per foot, that's the most economical, that meet the SX of this one. SX equal to 81.6. 81.6 inch 3-inch cube. And of course that, as you can see, it's greater than 66.67 inch cube that we want to have. So that's the answer you have here. And again, if you are not sure how to select the most economical, review worksheet 5C that we already do that. With that, we're done for worksheet 8C.